Hello everyone, this is Nithin and today we will be designing a foundation for a building. So here is the problem statement. So we need to design the foundation in such a way that 4 columns in each row and 4 columns in each column. So according to the question, it is very clear that from the plan view the distance between two successive columns need to be 6 meters, and it is also given that the safe bearing capacity of soil as 300 kilonewton per meter square and allowable settlement as 1 centimeter. And the dimensions are for the columns which are outside. It means for these 12 columns the dimensioning is 500 by 500, whereas for the inner columns, that is C6, C7, C10 and C11, the dimensioning is 600 by 600. It is also given that the materials that we need to use is for concrete, M40 concrete we need to use, and rebar of HYSD 415 we need to use, and has given dead loads and live loads of each column, and the subgrade modulus I have calculated as it is the ratio of safe bearing capacity to allowable settlement. So I got subgrade modulus as 3 into 10 power 4 kilonewton per meter cube. Column strip width is 0.25 L1 or L2, which is less, as both are equal. 0.25 into 18, 4.5 meters. I am taking it as approximately 4 meters. Okay, now let us go to safe software and let us go with the project. Yeah, here is our safe software. Now firstly we need to select the model. Go to file menu, click on new model. Then new model initialization dialog box will be displayed. Go to design code and select IS 456 2000 Indian standard code, and go to design preferences, minimum cover slabs, and clear cover top need to be 50. These are some standard values, and clear cover bottom need to be 50. Preferred bar size, this time I am using it as 22. Most probably we will be using in our daily life 20, 22, 18 like that. So and now click on OK. I will be taking the grid only template, and now I need to initialize my grid lines. As it is 18 mm by 18 mm, the footing area dimensions 18 meters by 18 meters. So with 1 meter spacing I need 19 grid lines in X direction and 19 grid lines in Y direction. The spacing is 1 meter in X direction and 1 meter in Y direction. Now click on OK. Now my dialog box, my plan view of grid is displayed here. Now go to define, and now I am defining the materials which I am using in order to construct my foundation. So in materials I need to use concrete and rebar of M40 and HYSD 500 respectively, but I not found here, so I am adding them. So firstly I am adding concrete of M40 grade. So the concrete, and weight per unit volume is 25 kilonewton per meter cube, and modulus of elasticity of M40 concrete is 31622.7. These are some standard values, and coefficient of thermal expansion is 0.000055, and concrete cube compressive strength is 40, as this is M40 cement. Now click on OK. Now my M40 concrete is defined. Now I need to define my rebar material as well. So it is HYSD 500 and the material type is rebar. Weight per unit volume is 77, and the modulus of elasticity is 2 lakhs. Minimum yield stress is 500 and minimum tensile stress is 545. Now click on OK in order to exit material property data dialog box. Click on OK to exit materials dialog box. Now again go to define, go to slab properties. Now I will be defining my footing here. So add new property. Now I am defining footing. So I need to design my footing with M40 concrete. So the slab material will be M40 and the type is footing. So click on OK and click on OK to exit slab properties dialog box. Now again go to define. Now I need to define my columns as well. So add new property. So actually there are two types of columns. One column is of dimensioning 500 by 500 and the other column is of dimensioning 600 by 600. So column 1 is of 500 by 500 and I need to design my columns with M40 concrete cement. And now click on OK, click on add new property and let us define our second column of M40 cement 600 by 600. Now click on OK to exit column properties. Now again go to define. Now we will be defining our soil subgrade properties, soil 1 and modify or show property, and we got subgrade modulus as 3 into 10 power 4, right? So I am giving it is 3 plus 0.4. Click on OK and click on OK. So now again go to define. Now let us check load patterns. So dead load and live load, it is fine. Click on OK. Now let us go to load cases. Yeah, we will be using linear static. Click on OK and go to define. Let us go to load combinations and I am adding new combination. Combination 1 is dead load and live load of ultimate strength, and in case of ultimate strength the scale factor is 1.5, right? So 1.5 and it is for ultimate strength. Select ultimate strength and click on OK. Now I am adding another combination, combination 2 and dead load and live load. This time service. In case of service the scale factor will be 1. So select service normal, service initial, service long term and click on OK and click on OK. So now we have defined everything. Now we need to draw our footing. So click on draw slabs or areas. So here our draw slabs or areas dialog box is displayed. So I am drawing my footing of 18 meters by 18 meters. 18 meters and downwards 18 meters. 18 meters and upwards also 18 meters. So now it is defined. So now exit from draw slabs and click escape. Don't forget to click escape. Now select this left click on this footing area and make sure that you have pressed escape. And now I am editing it. Actually I need to enlarge this area to 22 meters. So I am editing it. So edit areas, expand or shrink areas. I need to extend it with above extend 2 meters, which is equal to 2000 mm. So click on OK. So now my extended plan view is displayed here. So now my footing area is being drawn. Now I need to draw the columns as well. So go to draw columns and property below to none and make property above to column 1, and height below will be 3 and height above will be 2. And now place your columns with 6 meters of gapping, right? 6 meters of gapping, and these are your column 1. It means 500 mm by 500 mm. Yeah, now we got our column 1, and now change property above to column 2 and place your columns. Yeah, this is 6 meters and 6 meters. These are column 2s, which means the dimensioning is 600 by 600. So now everything is defined. Click on escape. So this is another column which I actually should not define, so I deleted it. So now we have defined our all columns. Now our task is to draw design strips. So now go to draw option and go to draw design strips, and firstly let us design strip A. So I am designing the design strip horizontally across the centers of column and right click to exit. And now here I am designing my next design strip horizontally. Yeah. Similarly, draw the design strip B vertically, starting from the top. Yeah, this design strip is not perfect. I'm going back. I'm drawing it again. Yeah, now it's fine. Now I'm drawing the last design strip as well. Now we have done with the drawing design strip, and I have closed the draw design strips dialog box. Now we have done with defining the elements and drawing the elements. Now we need to assign the materialistic properties and the loads to the footings and columns. Even the soil property we need to assign. So now click escape before going further, and you can check that on the left corner. And now select the inside area, and you can check here one area for edges selected. It is being displayed. Now go to assign and go to support data and soil properties. Now I am giving the soil property to it, and you can check the soil properties again. It is 3 plus 04. It's fine, and click on OK and click on OK to exit soil subgrid properties dialog box. And now the soil properties has been assigned to the footing. Now I need to assign the steel properties to the column. Firstly, let us check whether we have already assigned them. You can check them. Please be careful. You need to check inside the area but not the points. Yeah, here it is being displayed 1 point, so that's not wrong. You need to select the area inside it. So now it's fine. One area, 4 edges selected, and you can right click over that and design. So it's point, so it's wrong. It's displaying point. So right click on the area, and it is being displayed the rebar material as CSA. So we need to change it to HYSD 500 and click on OK. Click on OK again. So now you can check this property by right clicking. Yes, it's HYSD 500. Okay, now it's been assigned to all. Right, you can check further taking other columns also, and please be careful that you are clicking inside the area, and it's HYSD 500. Fine. Now we need to assign the rebar material to our design strips as well. Firstly, let us see those design strips, how they actually look. We are unable to see the design strip because they will be beneath the foundation footing. Right. So now let us see. You can see them. We have an option here, and here the design strip object, select label show with show stations, and OK. Now we can see the design strips, and this will be very confusing to go further, so I'm deselecting it again in order to avoid confusion, and click on OK. So now it's fine. Okay, now even we can see the how the columns by seeing the extrude view. Click on OK and go to 3D, and here we will be having the extrude view of our foundation. But we have not yet assigned any properties to it. The dead loads and live loads we have not assigned to it. We need to assign them. Okay, now go to XY plane, and I'm deselecting the extrude view as well, and click on OK. So now we need to assign the steel properties to our design strips. In this way, assign to every design strip. Similarly for the strip B's as well. And please be careful, you are typing on the design strips. Two more design strips. And this is my final design. Click on OK. Now it's fine. Yeah, this is not yet assigned. HYSD 500. Okay, now it's done. And click on OK. Now we have given the steel properties to it as well. Now we are left over with the loads. Actually, I have shown you the dead loads and live loads initially. Now we will be giving those dead loads and live loads to each of the columns. Starting from the column 1. So I will zoom it. Yeah. Click escape before proceeding. And now one area 4 edges selected, and afterwards go to assign, load data, surface loads, and dead load, and gravity, uniform, right. We need to select the point, and after selecting the now click on escape and select the first point, and as the dead loads and live loads of each column are different, you need to assign the dead loads and live loads for each column separately. So I am starting with the first column 1 point load, and firstly I am assigning the dead load, and the dead load is 1850, and the dimensioning is 500 by 500. Click on OK. So now I am selecting my second, so click on escape again. So this is the second point, assign, load data, point loads. The dead load to it is 3013.3, and we need to assign the live load as well, so I am assigning live load to it as well. So select this point again, assign load data, point loads, change this to live, and the live load given is 797.6. Select this point, assign load data, point loads. Dead load is 3013.3. Click on OK. Select that point, assign point loads. Live load is 1437, and repeat this procedure for remaining other columns as well. Yeah, in the meantime I have assigned the remaining dead loads and live loads to all the 16 columns. So now the assigning part is done. We have actually assigned the loads to it as well as the concrete properties to it initially, and before assigning the load properties, we have also assigned the steel properties to the column. We have already assigned the soil properties to the footing as well. So now everything is done. Just we need to check our analysis. So now go to run and go to run analysis. And in run analysis, now you need to save this name with a name. And as this is the final project, I'm saving it as with final project and save. Now wait till the analysis is complete, and the analysis is being done. Yes, now the analysis is complete. You can see the displacement values of the different slab regions are displayed here. Now the different displacements are being displayed here. So after this, what we need to do is we need to check our punching values, and even you can check the displacement values at each every place. And now go to display menu and yeah, you need to run an analysis and design, and now go to display, show punching shear design. So here the punching shear design values are really high. Actually the punching shear design values need to be like around less than 1, but here the punching shear values are greater than 1. It means that this is causing a failure of the foundation. So we need to change the thickness value. So now let us change the thickness value. So now let us modify this, because as the punching values are greater than 1, it is a failure. So now in order to make it success, unlock it, and unlocking model will delete analysis and click on OK, and after that go to define slab properties, modify or show properties, and thickness here is 200 mm, and let us change the thickness to 900. and click on OK. Click on OK again. So now again let us have run analysis and design, and yeah, now it's done. Yes, 2-1. Now let us see. Yeah, now let us see the punching shear design. So not all are here, some of them are not all less than 1. So again unlock it. Yeah, click on OK and go to define, slab properties, modify or show properties, and this time I am taking it to 1200, and let's see what happens. Click on OK, again run analysis and design. Yes, the run analysis and design is now being completed. Now display, yeah, show punching design. Yeah, now you can see all the values are less than 1. It means success. So now it is done. Now you can view the extrude view of it. So set display options and see the extrude view of it, and go to 3D, and this is the extrude view of our foundation. You can zoom it. Now go to XY again. Now let us we can see one more time this. This is the extrude view of our building foundation. So as the punching values of all of them are less than 1, it means that our foundation is success. So now let's have some analysis of it. So now I am seeing some reaction forces of it. So firstly let me take it as XY and let me remove this extrude view. Okay, so everything is less than 1, it is fine. Now I'm going to display show reaction forces. Close. Reaction forces is not necessary, and show deformed shape, and you can go dead load or live load. You can select any one of them and you can click apply, and you can see the deformed shape for it, and close. And even for the live load you can check that, and still you can know about loads. Dead load we can know. Click on OK. So it shows dead load. Go to 3D and it shows how the dead loads are acting over the columns. Now we can also know about so slab forces or stresses. Here I am going with the maximum bending moment of dead load. So apply, yeah, close. So this is how the maximum bending moment will be, curves will be. You can check at each point. Go to XY plane. Yeah, you can check the maximum bending moment at each and every point. We can also know about so strip forces, moment. We can get the moment diagrams for layer A, apply, and these are the bending moment diagram, and you can check the value at each point. So similarly we can check for live load the mag and click on apply. Yeah, so in this way you can check even for layer A, layer B at a time. Apply. So both for layer A, layer B. Now let us see how the shear force is varying. Apply. Yeah, this is how the shear force diagrams are. See, let's see how the axial force is. And torsion. This is for both layers. Apply. So this is torsion. Now let us check for dead loads as well, the torsion values, how they are, and this is for both layers. And now close this, and we can also know about show slab design, and here you can get about reinforcement. So this is the reinforcement for layer A, layer B at a time we can view also. So this is how it's varying. Okay, now let us close this as well. So this is how we can also see the crack widths. So apply. So these are the crack widths. Different colors, we can see the different colors. Different color shows different crack widths. Okay, the different crack widths that might occur on a column or foundation, that the crack widths will show how the width is. You can see all of them are very minute in mm. Yeah, it means a perfect foundation. And close that, and we can go to run detailing. So see, make sure that all these three options are selected and click on OK. Now everything is being done. Yes, now it's done. Now expand this, drawing components, footing views, drawing sheets, cover sheet, general notes, footing layout plan, footing table. Here, yeah, I went to drawing list, and this is the drawing sheet list. Even we can know about general notes, and the rebar shapes, we can know about rebar shapes, how the rebar shapes are. And now let us go to footings table. Yeah, it gives us about the footings, and footings table here as well, and footings bill of quantities. So it shows us the length of the footing and bar size and weight also it shows us, and rebar shape codes. This is all about the rebar shapes. Yeah, we have learned about these all. It's just the detailing report we need to go with. And similarly, slab or mat curtailment, let us look at this. So these are the top bars and these are the bottom bars, and it shows about middle strips, gives clear analysis of that. And even you can go with the footing layout plan. So this is the layout plan. So in this way we can analyze each and everything about the footing. So thank you. So this is all about the design of a building, that is the foundation design for a building. Thank you.